Welcome to Specialized Space, where we dive deep into the wonders of the universe and explore everything space-related, from mind-blowing discoveries to the latest in space technology. In a shock discovery, scientists have made the revelation of discovering an entirely new planet, unlike something that has been previously discovered. NASA, which is famously known for its pioneering space missions, has disclosed that the planet is not only incredible in terms of its size and location, but also because it emits light that appears to be of man-made origin. Are we on the verge of revealing secrets that would dramatically change our understanding of the universe? Does this discovery point towards the existence of life on other planets? By discovering NASA's phenomenal findings, we can easily get to the truth behind those mysterious lights. NASA launched the Dawn spacecraft in 2007 on a mission to observe some of the maximum interesting phenomena in our sun machine. Powered by 3 ion engines, Dawn embarked on its mission with the first order being a 14-month exploration of Vesta, the second largest asteroid in the asteroid belt. Dawn created exclusive photos and information that unearthed the sophisticated surface of Vesta, as well as several geological histories. Having completed its trial at Vesta, the spacecraft embarked on its second and perhaps most interesting phase, investigating the dwarf planet Ceres. Thanks to its ion engines, Dawn became able to break out of Vesta's orbit and journey to Ceres, which conventional chemical propulsion techniques would no longer be able to do. These engines created a soft push, allowing Dawn to travel enormous distances and establish a strong orbit around Ceres. Ceres was discovered in 1801 by Italian astronomer Giuseppe Piazzi and is the largest object in the asteroid belt between Mars and Jupiter. It was previously the smallest dwarf planet in our solar system before being reclassified in 2006. Ceres, which is approximately 950 kilometers in diameter, is not only the most important and largest object in the asteroid belt, but also one of the most interesting due to its unique roles. Researchers were in a rush to return to the principal specific images of the sky worldwide, and as soon as they arrived, they revealed brilliant locales scattered across its surface, most notably within an incredible crater known as a crater. These brightly colored areas raised alarms and questions immediately among the scientific community. Prior to Dawn's challenge, the nice picture we had of Ceres became a blurry, low-resolution photograph obtained by way of the Hubble Space Telescope. Not much was given much thought about Ceres, and the danger of finally getting up close was a huge discovery to make. The Dawn mission aimed to enhance our understanding of the Sun device's birth and how water contributed to planetary body formation. The bright spots on Ceres and on other asteroids could be caused by very reflective material, like salts left behind by sublimated water. This opened the door to the possibility of cryovolcanism on Ceres, a process in which volcanoes erupt liquid water or brine rather than molten rock. But what are those mysterious lighting? And what do they reveal about the nature of Ceres? Could they be evidence of active geological hobby? Or could they be hints at something even more wonderfully astonishing? Ceres is distinct from other asteroids in the asteroid belt due to its size, mass, composition, and possibility of containing water and ice. While most rocky asteroids, Ceres is made up more in a comet-like fashion, and that may imply it possesses valuable information regarding the early Sun machine. On a 2-year journey, the Dawn spacecraft commenced its alignment with Ceres early in 2015, marking a landmark moment for space travel. With Dawn's method, pictures of Ceres grew more vivid, showing a world that had been mysterious. The first pictures showed a floor cratered with craters, which indicated a history of impact. However, what truly captured the attention of scientists and space fans were the mysterious bright spots scattered all over the rocky terrain. With improving image resolution, scientists started taking an interest in attempting to commit to memory approximately the nature of these dazzling spots. Could they be patches of ice reflecting the sun? Or might they be something even more out of the ordinary? Speculation ranged from mineral deposits to potential signs and symptoms of cryovolcanic significance. Closer observation to their surprise discovered that the brightest area was not an individual function but rather a cluster of numerous individual spots. The overall concept was that those regions had been salt deposits that were deposited after water had sublimated. This suggested that Ceres must have, or at least does have, some form of geological process able to bring water or brine to the surface where it quickly evaporates, leaving behind shiny, reflective residues. These revelations flipped the traditionally held concepts of Ceres on its head, offering it as a more dynamic, more complex global than ever imagined. Groundwater or brine wallet discovery remains very significant for knowledge the potentiality of life in our solar device. The dwarf planet Ceres is a fascinating world, too often described as an icy global with a rocky, permeable surface. Unlike every other belt asteroid, made up in particular of metal and rock, Ceres is ideal for its particular makeup. Ceres' surface is made up of a mixture of hydrated minerals and water ice, such as clays and carbonates, which cause it to be less dense than its rocky friends. This composition reveals that Ceres has a humongous amount of water. Its surface is rocky but permeable, with ice and other volatiles embedded within, so it's closer to a comet than a standard asteroid. Ceres has an unusual indoors, made up of a soft mantle and a middle filled with water ice, which makes up about 50% of the planet's total amount. Ceres' mantle will probably consist of a mixture of rock and brine, including a denser core material like silicates. With such an enormous amount of water ice, Ceres may have once had liquid water, particularly if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from the surrounding asteroids and poses intriguing questions about its geological activity potential and the role water has played in its evolution. But that's no longer the whole story. The presence of ammonia clays at Ceres suggests that this dwarf planet may have originated in a more temperate part of the solar system and migrated inward. Ammonia, lowering the freezing temperature of water, should play a role in preserving surface brines. These findings no longer just add to our knowledge of Ceres, but also show significant clues about the processes shaping icy bodies in the Sun device. Cryovolcanism is a fascinating and relatively unusual geological method, especially when contrasted with the more recognized volcanic fascination we learn about on our home planet. While typical volcanoes erupt molten rock, cryovolcanoes expel materials like water, ammonia, or methane. They are fluids or gases in incredibly bloodless environments, and in addition to those around Ceres. Ceres cryovolcanoes are formed through the process of bringing water, which contains dissolved salts, to the surface. When this salty water comes into contact with the vacuum of space, it quickly sublimes, progressing immediately from a liquid or solid form directly into a gas. This disappears in leaving behind gleaming, mirror-like deposits of salt, producing the mysterious bright spots on Ceres' surface. The most famous of these bright spots is found in a crater called a crater, Spot 5. This area has been of considerable interest due to its high reflectance and episodic hazes observed by the Dawn mission. These hazes are caused by water sublimation, providing evidence that cryovolcanic recreation could also still be taking place, or could similarly have occurred fantastically recently on Ceres. Besides Spot 5, Ceres also has numerous other wonderful spots, with Ceres each having very distinctive features. The spots do not occur in one particular